Good morning or afternoon, everybody. Welcome to Understanding Pre-Painted Metal webinar, which is presented by Steelscape. This is another of our series of webinars from Metal Architecture magazine. I'm Paul Deffenbaugh. I'm the editorial director of Metal Architecture, and we're glad you've joined us. In just a moment here, I'm going to turn things over to Michelle Vondren, our speaker today. Michelle is going to take questions throughout the presentation, so please submit them using the panel on your screen, and I'll monitor the questions, then raise them with her at the end of each of the sections. For those of you who are looking for AIA credit or certificates, you're going to receive an email tomorrow about 2 o'clock Eastern time with information on where to send your request, as well as technical information follow-up and a bunch of other things, where to view the webinar again. So 2 o'clock tomorrow afternoon Eastern time, you're going to get a webinar. An email. Now I'm going to turn things over to Michelle. Michelle Vondren is Technical Manager for NS BlueScope Coated Products, North America. She graduated from California Polytechnic State University, San Luis Obispo, with a Bachelor of Science degree in Chemistry. She started her career as a research chemist with Morton, which later became BASF Coil Coatings, with a focus on polymers. This position also included lab development, as well as lab to production scale-up and manufacturing quality and process control. Eventually, Michelle's focus shifted to cool pigmentation, where she brought the first cool coil coatings to market. She was active in the Cool Roof Rating Council and Energy Star roofing program. She joined Steelscape as a quality engineer for the Rancho Cucamonga, California paint line. And while there, she has held the quality systems manager role and is now technical manager. She oversees quality systems and technical service for BlueScope Coated Products North America, which is comprised of Steelscape and ASC profiles. Michelle is an active member of the National Coil Coaters Association. She sits on the technical committee, as well as the Zinc Aluminum Coaters Association. Michelle, take it away. We're looking forward to hearing this.
Thank you, Paul. Appreciate it. Welcome, everyone. I hope everyone is staying safe and sane in these unusual times that we're going through, and have adjusted to working from home or wherever you're having to isolate. So thanks. We're going to go over pre-painted metal today. We're going to cover quite a few topics. Really, we have it broken down into 4 objectives. So understanding pre-painted metal fundamentals, the paint application process and why it works so well. We're going to talk about the 3 different types of paint systems and what makes them different or better from each other. We'll talk a little bit about enhancement options, customization that can be done for this kind of product. And then we'll talk about durability and warranty issues at the end. So what is pre-painted metal? It's fairly self-explanatory. So this is giant rolls of steel or aluminum, which are painted in a factory environment, and the paint is cured on to a solid finish. I had for years used the analogy of giant rolls of toilet paper, which takes on a bit of a different connotation these days. But we're talking about 20, 30, 40,000 pound rolls of steel and aluminum. So not something that's easy to hoard. So yeah, these giant rolls of steel or aluminum are painted first before they're formed into their final parts or pieces to go on the exterior of a building. But they're not all the same, and there's a lot of differences between them we're going to cover today. So our first spotlight question that we'll be able to answer through this next section is, how is paint applied to metal for the majority of building applications? It's rolled on for the most part, but not quite rolled on how you might be familiar with, painting a room in your house. It's a little bit different process than that. Here we have a diagram of a basic paint line or a coil coating line. We typically refer to it as coil coating in the industry. This is from the National Coil Coating Association, and there's also videos of this online if you want to check out an actual moving line. It's quite large, quite dynamic. It's a continuous process. The metal is cleaned first, then the paints are applied and baked on. This process is typically anywhere from 100 to 700 feet per minute, so it's a quite fast process. And the curing, the drying of the paint usually only takes about 15 to 30 seconds. So very, very quick. I like to compare this to the automotive world. Most people think of automotive paints and coatings as sort of the end-all be-all of industrial coatings, and they're very, very good. And there's a lot of crossover between automotive and coil coating as far as technique and chemistry. But cars, a whole car these days takes about 30 minutes to 2 hours to finish. Whereas we can paint enough coil through the coil coating process to build anywhere from 3 to 4, 5, 10 buildings in a matter of minutes. So it's a very different scale. So coil coating is the fastest and thinnest coating process in the industrial coatings world. This brings a lot of advantages to the table. So the substrate is cleaned and treated prior to the paint going on, and this all happens very quickly and in close succession to one another. So you get an incredibly great adhesion of the coating to the substrate. It's done in a very controlled manner, so we get great consistency from run to run, from batch to batch, from coil to coil. It's a very efficient process as well. We're using very little paint. Typical paint system is about 1.4 mils thick. I'll do the math for you. That's 0.0014 inches. For comparison, paper is 2 to 3 times thicker than that. I'm going to layer a paint on that's thinner than paper. By comparison, most other industrial coatings, including automotive, are 2 to 5 mils in thickness, so a substantial difference in the amount of paint. And because all of this is done before the fabrication of the final part, these coatings have to be hard, durable, but yet flexible as well. So there's a lot of chemistry and science that goes into the paint to make this happen. The coil coating process, while we're using solvent-based paints, is a closed loop system. Our curing ovens capture and burn all the VOCs. We're not releasing anything into the environment, which is nice. However, there are a few limitations that come with this because of the scale of it. Like I said, it's very, very rapid. Once you're set up and running, right, you need to paint a lot of material to make it cost effective and make it efficient. So we typically run large runs of the same color all at once. This is why most metal panel fabricators have a sort of restricted or limited standard color palette, usually of 18 to 25 colors. Doesn't mean we can't do custom colors in smaller runs, but there are some cost and lead times that come with that. So that needs to be kept in mind. The quality control through this process is quite rigorous. As you can imagine, like I said, these paints and substrates have to go through a lot of handling and forming after the fact. So the paint companies do a lot of rigorous quality control on the paints. We do a lot of rigorous quality control on the finished product once the coil is painted. We've listed here some of the more critical ones. The T-bend test, this is where we actually fold the metal back on itself very tightly, and we look to see if the substrate or the paint is cracking or opening. We do a reverse impact test where we drop a hard, sharp weight on the surface to make sure that the paint adheres and there's no cracking or delamination. We check color rigorously, which is very important, especially in the design world, right? That color needs to be consistent throughout the whole coil, needs to be consistent across the width of the strip, and color needs to be consistent from run to run and batch to batch. We check gloss, we check film thickness, which is very critical for not only appearance, but also the long-term performance and warranties involved, which we'll get into later in the presentation. If you want to see any of those quality control tests done for real, I think there's videos on the Coil Coating Association website as well that you can check out, and you can see those tests actually being performed and what it takes. So I want to talk a little bit now about the layers of a pre-painted metal panel, sort of starting with the substrate itself, which, like I said, is usually a metallic coated steel or aluminum. Sometimes you see stainless and some other substrates, but it's usually steel or aluminum. So working from the inside out, you have your base metal, let's say it's steel in this case, with a metallic coating, usually zinc or a zinc aluminum alloy, which we'll get into some specifics here in a few slides on that. That provides corrosion resistance. After that, we have a pre-treatment that's applied, which helps with adhesion and again, corrosion protection long-term. After that, there's almost always a primer applied to both sides of the strip. Primer does a couple things. It helps provide bite and adhesion for the top coat that's going to go on. It also adds in another layer of corrosion protection. Then we have the top coat on the top side. That'll be the color or the pattern that was chosen for the installation. And on the back side, we usually have what we call a backer or bottom side paint, which is there for protection and might also be seen depending on how the installation is done. So it needs to be visually pleasing as well. And then there's optional clear coats, which again, we'll talk about a little bit more detail later on. So the metallic coating portion on the steel is really important. And there's the two most common, of course, are hot dip galvanized and galvalume or zinc aluminum. Hot dip galvanized is 100% zinc coating, been around a very, very long time. Most people are familiar with it. Galvalume or zinc aluminum are trade names for a 55% aluminum, 45% zinc combination, which the aluminum offers enhanced corrosion protection. And that 55% ratio is the optimum ratio to get superior performance out in the field. It's been around quite a long time now. We do see this product spec'd a lot in the architectural specs for monumental type buildings, government jobs, because of its superior performance over galvanized. The reason it's so good is that the aluminum portion is inert, so it provides a protective barrier rather than just sacrificial, which is what the zinc does. Most of these types of substrates come with some sort of corrosion warranty. If they're licensed, you do have to be licensed to make this product. BIEC is the license holder and manager of that product. Most of the corrosion warranties out there are 20 to 25 years on average, which is not something you're going to get on just straight galvanized steel substrate. So then we move on to the paint portion. The fun part, really, the part we see, the part that's designed around. What is paint? I think most of us know what paint is, right? It's a liquid designed for application to a surface in a thin film, cures to a solid film. It does two primary things at the end of the day. It protects the surface of whatever it's on, and it creates the desired aesthetic. And as we just reviewed, the methods for application can be quite varied: brushing, dipping, spraying, vacuum coating, and rolling. Large scale rolling is what we do, what we're talking about here today. There's a lot of components to paint, and this is where we're going to talk a little bit about chemistry. I'm not going to make you do any chemistry, I promise, today. No math either. So the primary components of these paint systems are broken down into four: resins or polymers. That's the binder of the paint and determines most of the physical and chemical properties of the paint system. Pigments, which obviously is the color and look of the paint. Solvents, we got to make it liquid so we can apply it. In our case, in our industry, they are petro-type solvents, hydrocarbon type solvents. We don't use waterborne systems very often. That's pretty rare. And then there's additives that are used to fine-tune the coating, either for performance enhancements or particular end uses. Here's a summary of what each of these sort of bring to the table. The resin, again, really is the backbone of the paint system. It's going to provide the durability, hardness, flexibility, adhesion, gloss, corrosion resistance, chemical resistance, long-term performance out in the elements. The pigments, while mostly aesthetic, color and hiding, they do also provide corrosion resistance, film strength, water resistance, and it's not listed here, but UV performance, right? That we don't want them to fade. And again, the solvents are for really the application side, you know, and all those solvents are gone in the finished product. They're not left, but it allows us as the applicator to be able to pump it, right? They come in 50-gallon drums. We got to be able to pump it, get it into the coater head, have good flow, easy cleanup, be able to control film, those sorts of things. So if you look at how these components make up the composition, this is a typical sort of average weight percentage. The resin is a lot of it, again, with the solvents in the liquid form, which are gone by the end. Then the pigments, your pigment to resin or polymer binder is typically pretty equal. So there's a lot of pigments in these systems. And then the additives are very small. So how do you pick, you know, the right paint? There's a lot that goes into this, right? So you need the right balance for the end use and what you're going to do. You know, on the one edge to the left there, we've got very soft, flexible coatings, which might be good for particular end use, but you know, they might not have great impact resistance. They may scratch easier. And then on the other extreme, you have very hard, brittle coatings, which may have better performance in some aspects, but you know, you might not be able to bend it into a panel. So we're always trying to find some happy medium in between the two when we're formulating a paint for pre-painted metal. So then if we get into pigments and color, pigments are insoluble solid particles. We have to grind them really finely to disperse them within the resin to get good stability and good consistent color. There's two different kinds of pigments that we use in this industry, primarily inorganic and organic. Inorganic pigments are your very bright primary colors, which are pictured here on the slide. Those are going to be bright blues and greens and reds and yellows. Inorganic pigments are going to be a little bit duller, more earth tones. They're typically, you know, mined out of the earth as iron oxides of some sort. And the organic pigments provide a very clean and distinctive look and are very pretty, but they typically don't hold up real well out in the sunlight long term and fade very quickly. So we tend to lean towards the inorganic pigments for the high-end paint systems that need long-term performance on a building. And the science of color is very important in our world as well. Right, obviously color is the eye's perception in the visible wavelengths. We can do this numerically and with computers. Represented as an LAB number. L is A dark, A is the red green scale, and B is the blue yellow scale. All of our, most of our painted products are assessed by a computer for color, but also with a visual eye at the end of the process, and very, very tightly controlled. Controlled at a level that the human eye cannot perceive, but the computers can. So I don't know if we want to stop here real quick for some, if there's any questions.
Hi, Michelle. We've got a couple of questions here. Jack is asking about when you're putting all those layers on during the run, are the layers applied in the same run? I think he means.
Yeah, excellent question. I should have made that more clear. Thank you. So most paint lines can do 2 layers of paint in what we call one pass. So we do primer, bake it through the oven, it goes to the finish coater, gets its finish coat, goes through the ovens, gets baked, and it's done. If we need more coats than that, then we would put the coil back through the line and add additional paint. But typically you can do 2 layers, top and bottom, in one go.
Great, thank you. And the second question here is from Philip. You may be addressing this later in a later section, but he's asking what the weathering ability of bonderized finish on panels.
I'm not going to get into bonderized specifically in this presentation. I can tell you that bonderized was developed many, many years ago, specifically to help combat acid rain issues in the northeastern United States. That's where it sort of originated from. So it does that. It's a treatment. It's a pre-treatment under the paint. It does have some enhanced corrosion performance, especially in acidic environments, although we as a country have done a very good job of reducing acid rain, and it's not so much of an issue like it used to be. But no, that is not specifically going to be in this presentation. Sorry.
All right, well, Philip can follow up directly with you when he sees the link email tomorrow. That's what we have for now. I'll field questions going forward.
Okay, thanks. So the next section here is going to be the common paint systems and their differences and attributes. So can you name the 3 common paint systems used in building applications? Well, you're going to be able to here shortly. So the 3 that we deal with the most are what we call polyesters, silicone modified polyesters or SMPs, and fluorocarbons or PVDFs. Unfortunately, we as an industry have decided that fluorocarbons need to have about 8 different other names just to add confusion to the mix. So polyesters are almost always polyesters. Silicone modified polyesters are almost always referred to as SMPs. However, fluorocarbons go by a whole range of names, and I've listed some of the most common ones here. PVDF, polyvinyl fluoride. That's the hardest chemistry we're going to have today, FYI. That is also known as Kynar 500 or Hylar 5000, and that Kynar and Hylar name are probably what you would see most often in architectural specs and Corps of Engineering specs. They are registered trademarks. You have to be licensed to use that resin or polymer chemistry, and there's some very tight guidelines around its use that have to be followed as well. These are listed from best to great. But we're going to see that there's a lot of range, especially within the polyesters and what they can do. So polyesters have the widest range of formulation and can be used in the widest range of applications, everything from interior non-exposed components to exterior components. They're very cost effective. They can have great flexibility and hardness. They come in a wide range of colors and gloss options. Very, very versatile. We typically see it for exterior use in gutters and downspouts, rainwater goods, agriculture and light commercial, and appliance wrappers. But again, I always like to point out the flexibility of polyesters with this example. So think about polyester paint that's on this lovely little outbuilding that we have here versus the polyester clothing you might wear. Same base chemistry at the end of the day. 2 very different outcomes in how it's formulated and made. So polyesters run the gamut. Silicone modified polyesters are just what they sound like. These are polyesters that have had a silicone modifier added to their backbone that gives them improved weatherability and durability out in the field, improved resistance to chalk and fade. Still available in a wide range of colors. A little bit better cost point than the PVDFs, which are the high end, but maybe a little bit more expensive than polyesters. We see SMPs used a lot in light commercial and residential. They're a really good product for those end uses. The fluorocarbons now, this is the Cadillac. This is the end all be all. It has been for a long time in this industry. Go by several names, but they have superior and exceptional chalk and fade resistance. They hold up well in aggressive environments, whether that be industrial or marine, great chemical resistance. They have excellent formability. And we see these again on high-end architectural projects, monumental type buildings, and anywhere it's specified, and where you need good weatherability. They really are great products. I like to point out, to put it in some context, PVDF is 1 atom removed from Teflon. So this is the closest cousin to Teflon that there is. And most people can wrap their head around Teflon and how durable that product is. So this is a very close cousin. We don't work with Teflon directly because the heat's required to make Teflon into a form that's manageable isn't really feasible. And very hard to get it into a liquid state. like we need for the application process. So this is sort of the next best thing. So here's a nice little cheat sheet summary of these three main systems. And again, these are not the only paints that we use in the pre-painted metal world, but they're the three most common for exterior building applications. So the polyesters can be good to better, they're cost effective. Warranties on them range from none to moderate, like 20, 25 years. Their durability is limited to good, very versatile, wide range of colors. They do meet the AIA 2603 621 specs. SMPs step up. You get a moderate price point. Warranties on SMPs can be quite good. We're seeing anything from 25 to 40 years now in the industry. Durability is medium to high, and that's sort of dependent on pigmentation that's used, not necessarily the resin itself. Wide range of applications, and again, meets AIA 2604 better and 621. And then the PVDFs or the Kynar, really the best overall paint system, but a high price point, but very long warranties. We're seeing warranties 30 to 50 years in some cases now, which boggles my mind a little bit. The best durability you're going to get out of the paint systems. Again, high-end architectural, commercial, high-profile projects primarily. Excellent shock and fade resistance and chemical resistance. And it is a spec to AIA 2605 and 621. So what are the considerations, right? So, you know, all these paint systems are out there. It's a bit overwhelming. How do you just sort of decide what you want to do? So these are the things to keep in mind. First of all, again, because of the wide range of polyesters, they're not all the same. So if someone's thrown out, oh, a polyester will be fine, you probably need to ask a lot of questions, find out what the warranty really is, and is it a polyester that's really designed for exterior application. These days, the differential between high-end polyesters and the SMPs can be marginal. The very high-end polyesters have gotten very, very good in the last 10 years and do have very good performance. So they have closed that gap considerably. However, the PVDF is still going to be the best UV resistance for optimal exterior durability. Again, the Kynar and Hylar name is a trade name, and you have to be licensed. If a paint supplier does not have a license to use that product, they cannot use those names. And that sort of is more of a concern out of product coming in out of Asia is typically not licensed. All the big US manufacturers are licensed and good to go. And you got to use at least 70% of that resin, that PVDF Kynar resin in the overall resin composition to get good performance. Anything less than that's really not going to perform very well. So I'm going to pause again on that for questions.
Yeah, hi, Michelle. We've got a couple of questions here. Tyler's asking about cold weather performance of paints in Alaska. Are there some paints that perform better? Do all paints perform the same?
We've not seen, once installation is done, not much difference in performance versus warmer weathers. The one thing we do run into in cold weather is the actual forming of the metal. When a fabricator has got coil and they're forming panels, if it's done in cold weather, there can be issues. The paint might crack or undergoes a phenomenon that we call hazing, where you get like this blushing effect on the paint until it warms up again. So not too many issues once installed in the cold climates, but anyone who's forming or roll forming products in a cold climate needs to use some caution. And a lot of those guys actually use infrared lights and heaters on their equipment to warm the steel and the paint up a little bit before they form it to avoid those problems.
Interesting, thank you. And a second question here from John, who and you kind of talked about the one of the drop tests, I think you called it. He's asking about the long-term corrosion resistance from hail impact on different coating types.
Yeah, that's a good one. I write a lot of I write quite a few letters a year on hail damage. If the hail has not penetrated through the paint to the substrate, long-term performance is typically not compromised. However, if an opening in the paint system has been created, yes, you do run the risk of then having some delamination or corrosion starting. in that opening. So it really does vary, you know, case by case. I look at a lot of pictures and have assessed quite a few roofs over the years with hail damage. And typically, if the hail damage is bad enough that you can see the dents and the damage, you probably need to replace the roof. That said, though, most finished pre-painted metal panels that go out the door have a very high hail-resistant rating compared to traditional substrates like asphalt shingles. So they're less prone to the damage, but it does occur and it can compromise the long-term performance, and it can void the warranty. There is an exclusion in most warranties for damage due to weather.
I've got a couple more questions here, but I'm going to let you go on and we'll circle back to those.
Okay, very good. Thanks. Good stuff. So the next section is about enhancement options for pre-painted metal. So what are the building considerations that we need to keep in mind? And there's a lot, unfortunately. So proximity to salt water. We know salt water can be highly corrosive and damaging, so that we got to keep that in mind. Building energy efficiency. Desired colors or special effects or patterns that might be desired. How visible is the roof? We're going to talk about glare and shine off of roofs, which can be a problem with metal. We'll talk about some precautionary stuff about the mixed use of materials and what that can lead to out in the field. So we've broken this down. This is not all of them. These are just sort of the more common ones we run into that we deal with on a regular basis for enhancements. One would be micas and metallic pigments, clear coats, what they can and can't do, marine and industrial enhancements. So it would be marine or industrial settings, graffiti resistance. We're talking about cool roof pigments, energy efficiency, textures, and then prints and imagery that can be done. So micas and metallics are actually fairly common these days. Most panel manufacturers actually have a few metallic colors on their standard palette. Historically, back in the day, you used actual real metal flakes to achieve this sparkly, shiny look, but that has progressed to mica pigments. But we still use the term metallic in the industry, but the majority of them are actually mica pigments. So you get a sparkling or light catching effect. There's also pearlescent or color shifting pigments available. Some of you may have seen that used on cars more than on buildings, but they are out there and available. And I would say that one project I can think of, anyone that's on the West Coast, you can Google pictures of it. The cruise ship terminal in San Diego is a color changing effect installation, and as you move around that building, the color changes from sort of an aqua blue to a dark blue. It's quite impressive and very pretty. So those are out there and available. However, this is the do not do part when it comes to micas, and I don't know why this slide is a little not formatted great, but anyways, the mica pigments, their orientation of how they lay out in the paint is very important, and they're directional, what we call directional. So when you look at it from one direction, it looks one way. You shift to another viewing advantage, and the color visually shifts a little bit. So you got to be really careful when you install these. Both of these examples here are silvers that were run out of one batch, one coil, all at the same time. But during installation, the installers flipped a panel 180 relative to its adjacent panels, and you can see the visual difference. One way we combat this is to put directional arrows on the back side, so they all get installed going the same direction. But they are batch sensitive too. So if you're going to do a project that's got one of these micas or metallic paints, you really want to run all the material at one time out of the same batch of paint and at the same time on the coil coating line. Extreme environments. This is something we deal with a lot, especially Steelscape, a company I work for, being primarily a West Coast company. We do a lot of work near the ocean in proximity to salt water. And we have ways to combat that. There are paint systems that are modified and enhanced to deal with the extra corrosion potential that's there. There are coastal and marine paint systems available that can still come with a warranty. It's probably not going to be as long as a regular paint system, but it is still warrantable. These typically include what we call high build primers and or the addition of clear coats to give some extra protection. And these will be 3 to 4 layers. I know someone asked earlier about how many layers of paint you can do at one time. These marine and or industrial environments, which would be like chemical processing plants, mining operations, we typically have to put that coil of metal back through the line at least twice to get enough paint on them to go to these environments and perform. So then the other thing that clear coats can do for us is they can provide extra UV fade resistance, especially over organically pigmented. We talked about the organic pigments earlier. Those bright exotic colors, primary colors, don't hold up well, but you can put a clear coat over them that's got transparent sun blocker, UV blocking technology built into it to help protect them long term. Can also be added to get higher gloss and add a sort of depth to the final product. Can also increase hardness and mold resistance and antimicrobial. We do have antimicrobial clears. Don't see those used in exterior applications too much, but they're used a lot for walk-in coolers and food storage situations. And then it's cut off on my slide here, but graffiti resistant is a big deal. So there are clear coats out there that it's very hard to get anything else to stick to them. Paints or inks or pens, you just can't even get anything to stick to them. And if it does stick, they are formulated to be very easily cleaned off without leaving any kind of shadows or trace of the graffiti on the surface. But yet another cautionary tale. This one's not so bad. So if you're going to use a clear coat, or if a clear coat is needed for some reason, you do need to understand that clear, while we call it clear, does slightly alter the base color visually a little bit. These clear coats are actually have a very, very slight yellow tint to them, which is the UV blockers that are used in them. So on lighter colors, an example here, you can see from left to right is no clear coat, and then with a high build primer, which can also affect color, and then with a high build primer and a clear coat, you can see that lighter color shifts yellow a little bit visually, but the medium and darker colors, you can't really perceive it. So just a caution, if you're going to do a job that needs a clear coat, understand that it might shift the color a little bit, and that can be overcome with a reformulation of the color coat underneath in a lot of cases. Backers or bottom side paint. This is the back side of the coil or the strip. It's often sort of taken for granted and overlooked because they're usually not seen. But we still apply them. It helps with transit abrasion and corrosion and formability to have paint on that back side. It's typically an off-white or a light gray, some kind of neutral color. Excuse me. However, you know, eaves or overhangs, it might be exposed. You know, the people are going to see it, so it does need to have some color consistency and control to it. That said, most paint coaters, coating operations can do double-sided paint. So if you wanted red on both sides, that's doable, right? If that backside is going to be exposed and you want it to be an actual color, that can happen. Now we'll move into the cool colors, which, as Paul said early on, I was very involved in the development of these and launch into the market. Probably the biggest advancement and change in the coil coating world in the last 20 years, which has been fantastic. And so what happened is that one of the pigment companies was able to come up with pigments that reflect infrared heat without changing their visual color appearance. And the infrared wavelength is where heat generation occurs on surfaces, so that's important. So this allowed us to develop dark colors, visually dark colors that stay cooler than their non-cool counterparts. Any paint system can be modified to be cool. It's all about the pigmentation, doesn't have anything to do with the resin or the polymer. And it does truly minimize heat buildup and reduces cooling cost in warmer climates. And actually, this has really become standard. Most paint companies, especially in the PVDF or the Kynar paint lines, are formulated with these cool pigments as a standard. You don't have to request it anymore. It's become the norm. So there's quite a few terms out there that can be a bit confusing around cool pigments and cool paints. So we'll go over a few of those here. Solar reflectance is a big one. This is the amount of solar radiation reflected off a surface. It's measured as a percent. Emissivity is how well a surface dissipates heat from itself once it's gotten hot. So that's important. We know things are going to get hot in sunlight, but we want them to be able to cool or shed that heat well. Those two values are then plugged into a very long, nasty calculation that gives you the solar reflective index value. And this SRI value is what we see now in most of the codes. Both LEED, obviously, you guys are probably familiar with that, references SRI values. A lot of state and local building codes, especially California, use SRI requirements now as well. The Cool Roof Rating Council is the primary third party that validates this and measures this for manufacturers. One interesting thing about pre-painted metal that is a huge advantage is that its SRI value does not deteriorate over time like other roofing substrates do. So, you know, typically it's an initial rating and a 3-year aged rating. And you will see if you go online to Cool Roof Rating Council that pre-painted metal 3 years out from its initial has the exact same SRI value it did initially. And you can go 10, 20 years out and that SRI value does not deteriorate on pre-painted metal. And it's because these coatings have such great durability. They're not degrading, they're not fading, they're not changing over time, which we think is a huge advantage for this product. And here's some of this is the LEED 4.1 specifications for SRI. Low slope moved up to 82. I think it used to be 78 or 79 way back when. And then steep slope is now an initial SRI value of 39. For low slope roofs, I will tell you, to get an SRI of 82, you're talking about whites and light colors only. For steep sloped roof, you can get down into your medium colors and still reach that value. The other item that has come up more and more in recent years is light reflectance or glare off of metal roofs. And this is can be perceived as a deterrent to using metal, right? Is the glare, the shininess of it. This reflectance value sometimes gets confused with the solar reflectance value we just talked about, but they are two very, very different and independent values. Light reflectance is expressed as a percentage, and it's measuring the amount of visible or usable light that gets reflected off of a surface. Typically, lighter colors will have a higher value than dark colors, but not always. Texture can impact this. If you add some texture to the coating, it breaks up that glare or shine quite well, which is a plus in a lot of applications. We use a couple different terms around light reflectance, gloss and sheen in the industry. And gloss is the measurement of visible light at a 60-degree viewing angle. Sheen is measured at an 85-degree viewing angle. High gloss, high sheen on a paint system is going to result in a lot of glare, while a low gloss, low sheen is going to have a very flat or matte appearance. And we have some examples over there of how those values end up affecting the LRV at the end of the day. Low gloss, low sheen is typically defined in our industry as being less than 8. Most standard paints these days in the Kynar paint system is in the 10 to 20 range is pretty common. So it's not high, but it's not super low either. But we're seeing that, you know, there's still a need for very high gloss applications for accents and signage. But in the residential world, people are wanting to move to a more matte, less shiny finish. It's also an issue around airports and military installations have some pretty strict requirements about glare. Obviously, you don't want a pilot blinded by the shine off of a metal roof that impairs his ability to fly his aircraft. So we run into that. Mentioned textures. Textures are a great look. We're seeing more and more of these. They not only help with glare and shine, but they just give a really interesting depth and feel and look to a finished product. This is done a couple ways. The paint chemistry can be altered to cause the paint system to wrinkle up as it cures, or you can actually add particulates and texturizing agents to the paint to get this rough finish. The other very common enhancements that we see and has been around for a long time is patterns, not just a solid color, right? Solid colors can become a little boring. So rolling, print rolling, decorative type patterns can be applied to the strip. So it's the same paint systems that we've talked about are used. Development timeline to create the patterns can be pretty short. However, you do have to deal with repeat. Our applicator rolls are, a certain diameter and it's going to repeat. So you got to be a little careful that it's not an obvious repeating pattern on the finished product. Here's some examples here of sort of a faux patina, copper patina pattern, and then a brushed look at the bottom. And you can do these with a solid base coat in one pattern coat. You can do multiple pattern coats in different colors. Wood grain is something we're seeing more of as well. We can do wood grain patterns. The other less common, but they're out there, ways to get a pattern or an image is the use of laminates. So these are printed films that are then bonded to the metal surface. And we see these a lot for garage doors and interior applications. They don't have quite the same long-term durability as regular painted product, but the wood finish is really quite popular in this technique. The other new technology that's fairly new and has emerged in the last couple of years is digital printing. And these are basically giant like inkjet printers that go on a paint line. And you can print pictures, any kind of image you want in multiple colors. So it's large scale printing. And we're all a bit excited to see how this goes. The first lines utilizing this have just come on board in the last like 12 to 18 months. So still in its developmental phase, but could be very, very interesting moving forward with its capability. Okay, any questions on that section?
I'm going to just squeeze one question in here because I want to make sure we have enough time for this last section. Ron is asking, how do you spec the backer coats? Is there something specific you need to do to spec those?
Yeah, it depends. So if you don't have a discussion about the backer coat, it's going to be whatever the panel company's standard run-of-the-mill backer is, which is usually an off-white. But if your project, if that backside is going to be viewed or visible and you want it to look a certain way, then yeah, you need to have that discussion up front with your suppliers and the supply chain and spec it out in the request, which then gets passed on through the supply chain to us, the coder. And again, it can be anything from, a specific color, can be the same color as the other side, depending on what you want. And it could even be as simple as, hey, the standard backer is fine, but it's going to be viewable, so can you color control it? And that discussion can be had. So yeah, it needs to be known up front.
All right, thank you. I've got a few more questions here, but I don't want to short this section on durability and warranty coverage, so let's go ahead.
Okay, very good. So now we're going to talk about the durability issues and warranty coverages for pre-painted metal. So what are the common elements warranted? It's usually the corrosion of the substrate, which would be for the Galvalume or the Zincalume substrate only. No other substrate carries any kind of corrosion warranty. And then for the paint, it's going to be film integrity, shock, and fade. And we'll explain what those are here momentarily. So the durability of this product can be anywhere from 5 years and up. Like I said, we are starting to see warranties in the 40 to 50 year range. Typically, pre-painted warrants excessive chalking, excessive color fade, and delamination of the top coat or primer to the substrate, which is also what we call film integrity. These failures can occur for a couple different reasons. It can be improper application of the paint by the coater, it can be installation issues, it can be a poor paint formulation, it can be environmental conditions at the site. But we do see significant difference between paint system types as far as performance and warranty coverage. This example we have here has been around out in the industry a long time. This is a building in Japan that was built as an experiment in this blue color out of several different types of paint. You can see there's SNPs, there's the Kynar, there's polyester, and an acrylic, which we didn't talk about today. Acrylics were used much more frequently 20, 30 years ago than they are now. And then just over 15 years or so, you can see how significantly different the color fade has been between these systems. And like we talked about, you can see that the Kynar 500 really hasn't changed at all, while the S&P and the polyester have changed quite dramatically. So chalking, that's the first one, and this is probably the least understood. Chalking is exactly what it sounds like. It's the surface of the paint becomes white and chalky. It's a degradation of the resin system. The resin particles start to break down, and the pigments that are attached and embedded to those little pieces come off and lose adhesion and create this white powder on the surface, predominantly due to UV exposure. The high-end paint systems will offer warranties of 20 years plus against chalking, that this won't happen. There is an ASTM test for it on a scale of 0 to 10. The 10 being the best, the higher the number, the better. If it's a 10, it's got no chalking. That's how the chalk scale works. This is not something we see very often anymore. Failure due to chalking is pretty unheard of these days, and that has to do with improvements in the resin systems across all three of the main paint systems, as well as better pigment technology. Excessive color fade is a big one, right? No one wants a building that's going to fade quickly. They want it to look the same for many, many years. Fade, of course, is due to UV exposure, fading the pigments. It's measured numerically by a value called delta E. We can actually go out and measure the change on these buildings from beginning to end. The human eye starts to pick up color difference at about a 0.5 to a 1 delta E unit change. The PVDF systems warrant the smallest color change over the duration, usually 5 units or less over a 30 or 40 year period. So it's actually pretty small. I've got some examples here of blue and a red, and with the top being how it started, and then a 5 unit color change, and then a 7 unit color change. So while it's noticeable, it's not drastic. And what we find is more important on a building is everyone knows that colors are going to fade over time, but if they fade evenly, most people don't object too much, right? Because you're not going to see that there's a difference. However, the house here at the bottom is an example of, this was actually mixed paint systems on this roof. And you can see that the lower end paint system has faded quite a bit, while the 2 panels they used of a different paint system have not faded at all and has become objectionable. We call those candy cane houses when they've mixed paint systems like that. Delamination is another big one, and this is probably the toughest failure we see as far as determining why, because there can be a lot of reasons for it out in the field. So this is a loss of the paint film, either between the top coat and the primer, or all the way down to the substrate, and it can present in a lot of ways. It can be bubbling of the paint, peeling, chipping, cracking, complete loss of top coat. It may be small, it may be big. And the root causes are, like I said, lots. These are the most common ones. We didn't put enough film on it during the application process. We had an incorrect pretreatment, inadequate or extended curing. So when you cure these paints, if you under-cure them, they're going to fail in the field. If you over-cure them, they're going to fail in the field. So you got to hit the sweet spot. An incompatibility between top coat and primer. And this is a big one, is mechanical damage inflicted on the roofs, either during installation or sometime during their life. And my favorite story on this is I had to inspect the Tahoe High School many years ago, which had paint coming off. Got up there to look at it, and the maintenance manager volunteered to us before we started the inspection that in the wintertime, the children snowboard on the roof of the high school. And at which point we determined this was not a paint problem. This was due to snowboarding. So crazy stuff that happens to these buildings. The other type of failures that we see run the gamut, and these are not typically warranted or actually excluded from most warranties. And this is dissimilar metals, incompatible materials, swarf and metal filings, and wet stack or corrosion issues during transport or storage before installation. And then oil canning, which is not a failure, but something that everyone needs to understand. So dissimilar metals is a huge topic. I could do a whole webinar just on this. This is when you use a dissimilar metal. So we have the galvanic scale here. The further apart items are on this scale, the more reactive they're going to be in a corrosive environment. And again, the corrosive environment is important. So this is mostly in marine settings that we see this happen. So say you have a galvalume panel with stainless steel, which is what we have here. These are stainless steel light fixtures that were recessed into a zinc aluminum painted panel. This house was 200 feet off the surf break in Carlsbad, California. And within a year, we had this corrosion developing on the zinc aluminum panel because it's sacrificing itself to protect the stainless steel. The other incompatible materials we run into a lot is zinc aluminum steel should not ever be in direct contact with wet concrete. The concrete, the moisture from the concrete, that alkaline condition that exists attacks the aluminum and allows corrosion to start. There's an example here of concrete that was up against the painted zinc aluminum panels. This is the same house with the stainless steel lights in the prior slide, unfortunately. Treated wood is an issue. Treated wood actually is usually treated with copper. Copper leaching out of that onto painted metal is a really bad combination, and that leads to premature corrosion. Swarf and metal filings is an installation issue that we deal with on a pretty regular basis. So these are little metal shavings and filings that come from drilling the fasteners in or cutting panels on a site that are then not cleaned up. And these little particles get on the surface and they start to rust. And most people think it's their panels rusting, but it's actually these little swarf particles that are rusting, but they leave a permanent stain on the surface that's very, very hard to get off. And often the panels have to be replaced because of that. So we have a whole technical bulletin on that about how to cut properly, how to clean up immediately after, and if you do see some of this swarf developing, what to do about it quickly. Wet stack or storage corrosion is another issue with pre-painted metal that can be quite serious. And this is what, so when the panels are in bundles being transported or stored, you know, they're very tightly packed together and there's very little air movement, but moisture can still get in between them. And when you have moisture without the presence of air, that allows that moisture to migrate to the surface through the paint and cause corrosion underneath the painted surface. And the paint starts to bubble up and you get this sort of rough blistered appearance. So there's a lot of information out there about how to properly store information. It needs to be off the ground. It needs to be at an angle so water can run off of it. You know, don't use uncured lumber against it. Store it inside if possible. Zinc aluminum, galvalume does tend to hold up a little bit better in storage than galvanized on average. Oil canning, we've probably all seen this. Oil canning is an inherent issue with light gauge steel, especially. It's not a paint issue necessarily. It's not even really a substrate issue. It's just sort of the nature of the beast. So this is buckling, or a wave pattern that happens in installed panels. And there can be a lot of causes. It can be due to stresses in the base material, improper fastener pressure, misaligned panels, thermal expansion that wasn't accounted for. But there are ways to combat it, and that is specifying tension leveled material, which is pretty standard for all coil producers. You can use sniffer beads or striations in a panel design, and that's the example on the bottom. So this is the exact same profile of panel with and without striations, and you can see the difference in the buckling. Embossed surfaces help break this phenomenon up, and lower gloss coatings, while the oil canning is still there, if it's a lower gloss finish, you don't see it as readily. So how do we avoid these failures, right? Well, paint specification is huge. We've talked about that. The environmental considerations are important. Use a good coil coater who knows what they're doing, is going to apply the paint correctly. Don't mix batches or types of paint systems. You know, a reputable panel manufacturer knows how to package and handle the product prior to install. And then a good installer. Good metal installers can be hard to find, and not all contractors have experience dealing with metal out in the field. And then frequent cleaning and maintenance needs to happen as well. I mean, you don't ever not wash your car. It's the same thing with metal panels and roof. They do need to be washed down and cleaned periodically. And I know we're running tight on time, sorry. The last part here is warranties. You really need to understand warranties. A lot of warranties will have the headline of things like lifetime, 30 years, but you really need to read in to understand what that means and what's really being covered by the warranty. So they typically vary depending on the environment. There's some examples here, right? If it's industrial or marine, it's not going to be the same duration. There's going to be some special requirements around that have to be met. There's a lot of exceptions in all of these warranties that you should read through carefully about drainage and installation and maintenance and damage from acts of God. I'm sure you're familiar with that. You know, if you're specifying a paint or you're not sure about a paint specification, ask for sample warranties, read through them, and discuss it. Make sure it's what you're expecting. You know, like I said, non-uniform changes in appearance that result due to unequal exposure from light is typically not covered. Again, marine applications and industrial applications typically need to be pre-approved by the manufacturer to get a warranty as well. So here we are at the summary. I know that was a lot and we've run a little over, so I'm not going to read this to you. I think you guys all know what we went through. I will point out one thing real quick, back to my car analogy, right? So we've talked about all these pre-painted metal warranties, which are anywhere from 20 to 50 years these days, on a building, exposed to the elements forever, often with not a lot of maintenance. And a lot of people are surprised to learn that most of your auto paint warranties on your nice brand new cars that you have is only 7 to 10 years. So quite a vast difference with much lower film, as we discussed early on. Questions? I know we've run over. I won't bother you with the review. You know what the review is.
That was excellent, Michelle. You really packed a lot of information in
Sorry.
this hour. And there are a lot of questions, but I'm gonna only ask one or two at the most, because I know people are antsy and we need to wrap up. One of the questions is, if you do have a failure, what's the best option for recoating in the field, or is it just best to replace the panels?
You know, it varies by situation, and the two most common remedies are either panel replacement or repainting it in the field. And that decision is based on a lot of things. One, the scope of the failure, how large it is, and is it a panel that can be easily pulled off and replaced, right? Sometimes it's better to go with a repaint because you don't want to disrupt the structural integrity and the weather tightness integrity of the building, depending on the type of installation that was done. But those are the two most common remedies, either replacing the material completely or going in and painting it. And there are some very good field applied paints. There is a field applied Kynar paint that's available that is a quite good product that can be used if it's needed.
Excellent. And last question of the many we have here. Somebody's asking if you, in an exposed cross section at a cut, does that cause issues of durability if you have to cut the panel in that cross section?
It can, and there are technical bulletins and guidance on how best to handle that available by almost all the good panel manufacturers and the coil coaters like Steelscape that provide some guidance on that and the best way to handle that. And what type of tool to cut with is very important.
Thank you so much, Michelle. That was an excellent presentation and just a ton of information. It'll take people a while to absorb. I do know that a few folks had struggled to get on at the beginning and get their audio set up. So I do want to remind everybody that the presentation has been recorded and it will be available on the Steelscape website. You'll get an email directing you where to go there so you can catch up on maybe some of the things you missed at the beginning. The email about that and also about certifications and as well as AIA credits will go out tomorrow about 2 o'clock Eastern time. Thanks everybody for attending. We're doing another of these webinars on May 21st. I think we might change the time to later in the day so we're not jammed up with the problems we're having with people getting on in the middle of the day. That one is called Metal Roof Systems, Design and Installation Considerations. It's presented by AEP Span, and you can find all of the latest information on the webinar series on the Metal Architecture website at metalarchitecture.com/2020-events. Michelle, really enjoyed that. Thank you so much, and thanks everybody for hanging in through the technical issues there at the beginning. Great presentation. Thanks all.
Thank you, everyone. Take care.